Early in the 20th century, scientists said that an atom's nucleus is made of positively charged protons. However, later experiments showed that the nucleus couldn't be made up of protons alone. Other particles with a neutral charge that scientists called neutrons had to be part of the nucleus. This is because the mass of the protons alone was smaller than the expected mass of an atom's nucleus. So more mass was needed in a nucleus. Moreover, because all of the charge of a nucleus comes from protons, this new particle had to be chargeless. Additionally, a method for countering the repulsion between protons was needed. So protons are positively charged, and positively charged particles repel. Something had to counter this repulsion to keep the nucleus stable. Now, protons and neutrons together are called nucleons. No two atoms of different elements have the same number of protons, so you cannot have an iron atom and an oxygen atom with the same number of protons. However, two atoms of the same element have the same number of protons. So all oxygen atoms have 8 protons and all iron atoms have 26 protons. The number of protons then defines the element. So if you know that an atom has 26 protons, you know it's an iron atom. The number of protons is called the atomic number and is represented by the letter Z. Mass number, which is represented by A, is the measure of the total number of nucleons. That is, the sum of protons and neutrons in an atom. Now, both these numbers are whole numbers. You cannot have an atomic number of 1.5 because an atom cannot have 1.5 protons. However, the mass number, the actual mass number represented in the periodic table, is a decimal, like this. This is because this mass number is found by finding the weighted average mass number of many different atoms. So different atoms with different mass numbers are used to find this actual mass number. These atoms are called isotopes. Isotopes are atoms of the same element that have the same atomic number but a different number of neutrons. That is a different mass number. For example, you have carbon-12, which has 6 protons because it's a carbon, and 6 neutrons. And carbon-13, which also has 6 protons but 7 neutrons. In carbon-14, which also has 6 protons but 8 neutrons. These 3 are isotopes of carbon, and each one has different percent abundance. That is 98.9% of carbon in the world has 6 neutrons, and 1.1% has 7 neutrons. So to find the actual mass number, which is found in the periodic table, we find the weighted average of these mass numbers. The weighted average takes into consideration the percent abundance. It's not just an average, but an average that takes into consideration the percent abundance. And in the periodic table, carbon has mass of 12.01 because most carbons are 12. So this number is closer than to 12 than to 13 or 14. Now, atoms are normally electrically neutral. That is, they have no net charge. Because protons are positive and electrons are negative, the number of protons must equal to the number of electrons to cancel out all the charge in an atom. So, the number of electrons also equals to the atomic number. Now, some atoms are actually charged. For example, you can have an oxygen with a -1 charge. Those atoms are called ions, and they have lost or gained electrons. So a negative oxygen ion has gained an electron and has more negative charges than positive charges. Now, atoms are represented by a capital letter or sometimes a capital letter followed by a lowercase letter. For example, carbon is C and copper is Cu. Iron is F and lowercase e. The atomic number, which is represented by Z, and the mass number A are written as a subscript and a superscript. So the atomic number is subscript and the mass number is superscript. For example, if you have an element X, this would be the mass number and this would be the atomic number. Helium here has a mass number of 4 and an atomic number of 2. And carbon has a mass number of 12 and an atomic number of 6. The mass of a neutron is 1.675 times 10 to the power of negative 27 kilograms. And the mass of a proton is only slightly smaller than the mass of a neutron. However, these masses are too small to be represented in kilograms. So, a new unit was made. It's called the atomic mass unit. The atomic mass unit was made so that carbon-12 has a mass of 12 atomic mass units. The mass of carbon-12, which has 6 protons and 6 neutrons, is this number. Now they divided this number by 12 to get this number. This number multiplied by 12 is the mass of carbon, and it equals to 1 atomic mass unit. So carbon has an atomic mass, unit mass of 12, and 1 proton, which is only a little more than this number, is 1.0078 atomic mass units, and 1 neutron is 1.0087 atomic mass units. Now, scientists noticed that lighter nuclei have about the same number of protons as neutrons. Carbon, for example, has 6 protons and 6 neutrons. However, heavy stable nuclei have more neutrons than protons. So this means that neutrons help make a heavy nucleus stable. That is, they help overcome the repulsion between the positively charged protons of a nucleus. The strong nuclear force is an attraction force that attracts protons to other protons, protons to neutrons, and neutrons to other neutrons. This force acts at very small distances that are smaller than 10 to the negative 15th power meters. So basically, it's an attractive force inside the nucleus that attracts all the particles of the nucleus to each other to counter the repulsion between the positively charged protons. Now, heavy nuclei have more neutrons because they need to increase the strong nuclear force to prevent the repulsion between the protons from breaking apart the nucleus. Nuclei with more than 83 protons are too heavy and cannot be stable, so they have to transmute and become smaller nuclei that are more stable. Don't forget to subscribe, like, and always achieve more.